All right, ladies and gentlemen, welcome back. We're looking at part 3 here, and this is all about organic chemistry. So you guys have had a little bit of a background now into the basic chemistry we've been doing. Some of you guys even got to some organic in Chem 11. So we're just going to go over some of the basic stuff that you need to know in order to get through this biomolecules unit. Some of it's pretty tricky, so if you need to stop, rewind, or stop it just to write some of the pictures and structures down, feel free. And as always, we'll be going over this stuff in class. All right, let me bring my little screen up here. Okay, so first of all, what you guys might think of when you think about organic are these things. USDA organic approved, organic vegetables. That is not what we're talking about in terms of biology. What we're thinking about when we think about organic substances in biology or chemistry is that it contains carbon and hydrogen. There's a couple other rules that we had. They couldn't be oxides, they can't be carbonates, they can't be carbides. We're not too worried about the exact definition. All I want you guys to know that if it's a carbon and a hydrogen based molecule, which we consider a hydrocarbon, we say that it's organic. Just because it's a hydrocarbon, or sorry, just because it's organic doesn't mean it can't include anything else. The only basis is that it has to have those two components. Okay? Moving on. The next one, we have some examples of organic compounds that you're probably fairly familiar with. You've seen them before, but I just am showing you these two so you can see the different structures that they're written in. So we have CH4, which is methane. And you can write it a couple ways. You can write it just with the regular empirical formula, or you can write it like this, and it's more of a structural. So it'll show you the way that it's arranged and bonded. Same thing with propane, which you guys know, use it for barbecues. C3H8, or we can also write it like this. I'm just going to write it below. It has a 3-carbon chain, and all of the bonds are completely used up. Each carbon has a maximum of 4 bonds, 2 electrons each. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It fills up all of our chemistry needs. Okay, so that's just a couple examples. The next one here, functional groups. This is just something that's added to a hydrocarbon in order to give it a different function. So pause this in order to get it all down there. So hydrocarbons like methane and propane, if you add a specific group, like if we add a OH group to them, which is an alcohol group, they behave differently. So for example, ethanol, which is just a addition of an alcohol group to ethane, which is a 2-carbon chain. It turns it into fuel or a solvent in order to dissolve certain substances, or also, as people over 19 know, that they're also alcoholic beverages. So ethanol is the precursor to the alcoholic beverages that adults consume. So here's an example of it. You guys may or may not know this, but when they grow corn and grind it down and run it through a distillery, that's what actually creates fuels. So when you might have seen it where you have ethanol added gasoline. I think Mohawk, Husky, those ones have ethanol. So they use these corn crops in order to get it. So this is just showing a reusable resource. Okay, monomers and polymers. This is something that I'm going to really stress. It's tricky, so you might have to just try to find a way to wrap your brain around it. Otherwise, we'll be giving you guys some different mnemonic devices as we go. Monomer, mono means one. Polymer, poly means many. So for what a monomer is, it's a simple organic, C's and H's, that exist individually, so it can exist totally by itself, or if it links together with other ones, it forms a polymer. So this is kind of like the basis, okay? It'd be like one chain link, and then when you put more chain links together and make the actual chain, like in a fence, that would be the polymer. Here's some examples. So in biology, we have monomers and we have polymers. For example, a monomer would be amino acids. And when we link amino acids together, they form polypeptides, or another name, proteins. Other one's glucose, which is a carbohydrate. So I'll just put in brackets carbohydrate. And when you link glucose together, it becomes starch. Glycerol and fatty acids, monomers, when you link those ones together, it becomes lipids. Another name for that are fats, or a common name for them. And the last one is when we have nucleotides, like in DNA, which we're going to see in the future, and you might have seen in Bio 11. When you put those together, then you form nucleic acids like DNA and RNA. Okay, so just keep those in the back of your mind, the relationship between monomers and polymers. You'll have to know what the monomer is for each one of those polymers in order to be successful. So now let's just talk about what we actually can do to form those. Okay, there's two reactions to be able to make polymers, but then also to break it up to make those monomers. So I think I have it listed on your template as reactions that make monomers or polymers. The first one is a dehydration reaction. So what I want you to think about is, what does it mean to be dehydrated? So when you're dehydrated, it means that you're losing water. So this is where an OH and an H are removed from monomers in order to create a polymer and water. So let's just look what it, see what it looks like. So you're going to want to pause this to write it down. So if we have a monomer, and we're not going to be specific here on what it is, one side of the monomer always has a hydrogen, and the other side always has an OH group. Well, if we have that on the other side here with another monomer, it also has an H and an OH. So what happens when these two come together? Let me just change the color here. Let's do pink. When they come together, OH group from one and the H group from the other will come together, and it's going to form water. So what in essence is happening is that these are coming apart and these monomers are losing water. That's why we call it a dehydration reaction. So what that forms is an H and two monomers that are now joined through processes we'll talk more about in class, and then the OH. So it's two monomers joined together, which we call a polymer. That's barely legible. Polymer. Okay? So that's a dehydration reaction. So let's look at the complete opposite. So if you are hydrating or adding water, we call it hydrolysis. So hydrolysis, where we're getting rehydrated, is where we use water and it's being added to the polymer to create monomers. This is the complete opposite reaction. Let me just get a demo. So this is where we have our polymer. And I know what it's going to look like here because I'm still writing the other word. But they're joined together now, so it's a polymer. OH. Okay, so don't forget, even though that these are two monomers together, we call that a polymer. So what happens is water comes, and it has two functions. One, it breaks apart that polymer. But the other thing is that another water molecule comes along and it joins. So the OH of one part of the water joins, and the H of the other joins to create these new monomers. Okay? So water does one thing, it breaks, and then also it is broken apart and added to create the monomer. So it might be a little bit tricky just trying to wrap your brain around it right now. We're going to be doing some different things in class, hopefully to make that a little bit more clear, but I understand that it's a little bit tricky. So that's organic chemistry. What we're going to be doing next day is talking about the main components, carbohydrates, proteins, lipids, and nucleic acids. And that's going to be the tricky stuff. So please, if you can at all remember, bring in some flashcards so we can write down all the different molecules. It's going to be nice to be able to have some visuals. And just as a little wrap up, what should you know? You need to know the biological definition of organic, so pretty much carbons and hydrogens. Know what the difference is between a monomer and a polymer. Monomer is like the building block when it comes together and they're linked, they form the polymer. And then also formation of them, what's creating them, so know what the dehydration reaction is and the hydrolysis and what that forms. Okay, if you have questions, let me know. Otherwise, we will see you tomorrow. Have a great night.